Good morning, everybody. We have her Sony component lock. This is Sony component model. You see, I can read this because my eyes is very sick. You see, this Sony amplifier. The problem of this Sony amplifier is when we on it, there is a Sony demo, but we on this power lock on power on, and this is what happened. See, force power. You see, force power. That's the problem of this amplifier, this Sony component. So now let's dismantle it and check it inside what happened here. So now we're going to check first. We're going to check the amplifier, IC amplifier. So now we're going to dismantle this. It's a very big transformer, you see, very big transformer. Now let's dismantle it. Okay. Okay, we're going to now dismantle. You see, it's hard to open. So what you do now is to just align this. Okay, this is how to align it. You see, it's hard to open. So now let's align it right there. Okay, lock the position there. So we can now, if we pull or push this, you see, it's okay. You see, so now we got this out. Okay, so we had here the lights is very so how to open this? Just pull it up like this. Pull it up like this. Pull it up, yeah, and here it go. Just push it up like this. So now we have open. Some component have a lock here, yeah, at the back, and this kind of component, how to out this is to push it up. Okay. Now we can easily remove this. It's removing time. Put it there, put it here. Okay, look inside. This is the inside of Sony component. Okay, now we dismantle it. There is a 2 screw here, one here. Look, in the side of this component there's a screw, 2 screw here. Okay, here, 2 screw. So now how to remove this? Just pull and pull like this. Pull or push. Pull, yeah. And this is and we have another lock here. Just pull again, pull again. Okay, we pull it. so we can get it. Wow, what is the problem? Okay, now we're going to remove the board. This is the board. Okay, okay, okay. The board now is totally removed. Okay, the board now is totally removed. Okay, okay. Where we got? Where did it put? Okay, and now this wire, this 3 wire is the standby wire. Look and look here. Yeah. This is the standby. What's this? What happened of this? Okay. Maybe. Okay. This is 5.6, and this is the standby power. This wire. Look there. Okay. Okay. I'm going to remove this. Okay. It's now removing and remove this heatsink from the IC like this. Okay, now we're going to remove this IC in there and board. Okay, oh, it's too okay, it's okay. Now the bolt, so we can find it easily. Just put here like this. Okay, okay, okay. Here is the board and here is the IC. Now, wow, the IC now is already refreshing. Why? Because of this. This is not the original here. The IC now is replacing. Maybe the other technician replaced this IC because maybe it's defect. So now we're going to test it. Okay, we got the tester first. Okay, now we're going to remove this IC while the soldering iron is heating. We're going to remove this IC. Disclaimer lang. Don't do this like that. Use soldering fork to remove this IC. Don't do like what I do. Okay. Why I do this? Because I already suspected this IC is defect, so it is okay if I remove this. It's broken, it is okay because I suspect IC is defect. Okay. It is used for the professional only. Don't do don't do like that. Don't do like that. This is what the IC, if you remove like that. Okay, the number of this IC is what is sticky 442-130. Okay, we're going to clean the solder of the IC and plug it, and we see what happened. Okay, we remove this. Get the short. Okay, now there is no short. Okay, Okay, now we're going to check the positive and negative of this IC. We're going to put marking here so we can measure how many voltage. This is the positive. You see positive, because this is the common here, common, negative to positive, and this is the positive. So where is the positive go is here, here. This is the positive, and this is, we put it marking here, positive, and we get a pencil pen and we mark it positive. Okay, so that we measure it now. So where is the negative here? The negative is here, negative. So where did the negative go? Where did the negative go? Okay, the negative is here. So the negative is, where did he go? Go there. This is the negative. So this is the negative, and we're going to mark it. How to mark it? Negative. There is no, what do you call this? Negative. That's the negative. You see, that's the negative. Okay, this is the negative. There. So negative. Okay, now we are going to back this board so that we can check it, if what happened if we plug it without IC. So we're going to taodize this. We're going to back this. Okay, push it. Okay, it's okay. So okay, now we're going to on this and check what happened if there is no IC here. You see. Okay, now we're going to plug it. Okay, we now plug and see what happened. So this is now, you see, this is now, see now. You see what happened? It's the demo. Okay, demo get out, and now we on this power on. Now we can see what happened. One, you see, there is no power. This is no protect power. You see, the where's the one? Where's the ano dito? You see, the selector is functioning. Okay, you see, the selector now is functioning. Okay, so the IC now is not here because this is the IC. So this is how you test the component. The IC now is, we analyze that this IC is short or defective because when we remove it in the board here, the power is okay, no post protect. Okay, now we talk and analyze first. Okay, now we're going to measure the voltage of this amplifier. We set the tester in 250. Why 250? Because It is, I think it's a very big voltage going to IC because the capacitor is 71 volts. So where is the marking? So here is the ground. Let the component on and check first the voltage. Okay, this is the positive. What happened? You see, the voltage is very big. I think it's 65 volts. Positive 65 volts. You see, it's very big because the tester setting is 250. That the con is very big. So now let's go to the negative. Where is the negative here? This is the negative. Negative. Okay, negative to ground. We can, okay, negative to ground. Right. We can what? It's negative. Why there is no negative? Oh, you see, there's a negative. The negative here is why? Only 50 volts. The negative is only 50 volts and the positive is what? The positive is 65 volts. Mean to say it is unbalanced one. It is unbalanced voltage. You see? Almost 75 volts. The positive is almost 75 volts. But the negative is only 50 volts. Imbalance, not balance. You see, 50 volts. You see? Okay, I explain it. Okay, here is our explanation. What will happen? This is from transformer right there. This is from transformer. You see? Okay, never mind my one. So this is the diode. Okay. This is the what you call it, diode. The transformer here is here and here. See, and this is positive and this is negative. So we got capacitor here. Okay, positive to positive right there. Positive, negative, and the negative is here. Okay, and this is the ground. Here is the ground. Okay, now this is a ground and this is the positive and this is the negative. Okay, you see. Now this EC amplifier, this is the 0 and this is the what you call it, 60 volts EC and 60 volts EC. So now when we get the when we test this capacitor, this capacitor is around where did we around 65 volts, around 65 volts. You see, this is this capacitor is around 65 volts and this capacitor negative to ground is only around where 50 volts. 50 volts. It's only 50 volts. So the supply going to IC is 65 volts and 50 volts unbalanced supply. See, you see, 50 volts and 65 volts mean to say unbalanced. And IC, all supply is equal. Example, 65 volts. Here is also 65 volts. Unbalanced. So now we're going to check this capacitor. Why is it small? So most of the voltage, if it's small or uh, long voltage, is the problem is the capacitor. Now let's see this negative capacitor here. We replace it for the meantime to see what happened. Okay. Now we're already dismantling. So before you the capacitor, you better check first the voltage because there's remaining voltage. Okay, there's no remaining, and there is no also remaining. There is no remaining voltage. Okay, small voltage. Okay. So what happened now is why is this capacitor is too small. Okay, so now we're going to check. Okay, we remove this capacitor and try to check it with resistance. Okay, going to remove. Okay, the iron is not hot. We're going to remove these two capacitor. Okay. Why? Okay. There is the two. Here is the two capacitor. See, 2200. See, 71 volts, and the other is 2271 volts. Now we're going to test it times 1. So the one is silaw-silaw. Okay. Okay, we're going to test it times 10. Tester is set to times 10. Okay. You see, okay. Okay, you see. Look, the needle of the tester is in almost here 2. You see, almost 2. Okay, and this other capacitor, what happened? Open? This capacitor is open? Oh, okay. But it is okay also in the capacitor is like okay because it's here on 2. Okay, it's okay, and this other is okay also. You see, wait, what happened? This capacitor is not going to, it's not going to right there too. See, okay, now we reverse it. It's okay. This two capacitor is okay, but the voltage is small. So there's another way to check the capacitor. Okay, how? Like this. You shake it. You see, there's a there is a one inside. You see, You see this one, there's is shaking inside. So the best thing we do is we're going to replace these two capacitor. Okay, okay, okay. We are going to replace these two capacitor because it's already shaking inside. There's a shaking. If there's a shaking, it's the peak. Okay, so now we're going to replace it. This capacitor is 71 volts. So we're going to replace, we have no other capacitor. What we have here is only 100 volts, 3300. Okay, 100 volts, 3300. But it is okay to replace this. Okay, we're going to replace. Okay, now we replace the capacitor with 100 volts capacitor because we have no 71 volts here. It's only 100 volts. Okay, so before you can make sure that the positive and negative not turn. Okay, negative to positive. Okay, negative, positive, positive. Okay, it's okay. Now we are going to check it. Okay, now we're going to test this like this. So how we test like this, we are going to, this is the terminal of relay here. This is the terminal of relay, this is the positive and this is the negative, and this is the switch. Now we're going to direct first, we put a jumper here so that we we can test this directly. Okay, okay, put a small amount of wire, jumper wire. Okay, wow. I can see jumper this switch of relay. Okay, just a small wire. Boy, what happened? The jumper is not holding. Oh, we need a small amount of soldering lead so that our jumper is holding on. Holding on. Okay, now it's holding on. Okay, now we're going to on. Put the tester to 250 volts. Okay, now we check. No voltage. Why? Hey, you see? That's why no voltage, because the tester is broken. We fix it first. Okay. Off. Okay. Plug on. Negative to positive. 60. Look, the tester is 65 volts. 65, almost 65 volts. What kind of, almost 65 volts, and the other is also what, you see, almost 65 volts, and the other is also 65 volts. So now the current of this board is now exact, is now equal. So we're going to explain this. And now this is what happened. You see, I explain you. So this is what happened. This is the previous 50 volts and 65 volts. Now we replace the capacitor here. We replace the capacitor. Now the voltage now is equal na. This 50 volts now become 65 volts, and this is 65 or 65 volts. So now it's all equal, 65 0 65. So the voltage now is equal. So we're going to what? We back this IC, because we cannot conclude that this IC is defect because the voltage is not equal, abnormal. So we're going to back this IC. Okay? Okay? Okay. Before we back this IC, just short the positive and negative using this plug of this transformer, so that there is no high voltage. Okay. Okay. So before we back this IC, we're going to check if there is voltage remaining. Okay. No voltage. No voltage remaining. So it is free to back this IC. Okay? Okay. Okay. Now we are finished backing the IC right there. Okay. The IC now is already installed. We back the IC, and now we are going to test this. So now we're going to plug the power. Okay, this is the plug, and we plug it there and see what happened if the push protect is still. Okay, now see. Okay, power. So now let's on the power on. Where's the power here? Power on. Whoa, you see, there is no push power protect. You see, there's no push power protect. Okay. Okay. So not all push power protect the defect is IC. The defect of this we test first before we conclude. Okay. Testingan muna natin. Let's test first. So we put the speaker here. If there is a sound, because there is no push power protect. Now we're going to test it. Okay, finish installing the speaker. No sounds. Maybe the volume is up. We look at FM. Oh, oops. Oh, you see? You heard that speaker? There is FM. We put it to MD so that we can use our USB. Okay. Okay. AMD. Now I use USB. Here's my USB. Here's the cable. Here's the cable from USB. And put it here. MD. Okay. No sounds. Oh! There's the sounds. Okay. Replace the music. Okay. Wow. Soon. Okay, volume. Yes. Okay. Approve. Approve. Okay. the problem. We backing the IC and replacing capacitor here. So solve the problem. And this is the capacitor we replace. The capacitor is 2271 volts. Okay. This is the defect. If you tested it, okay, but if you shake it, oh, it's a kalog-kalog. It's shaking inside, so it is a defect. If shaking inside, it's a defect. Okay, okay. But the music now is very good. It's okay. Okay. Power up. Okay, now power on. Oh. Power on. Standby. Okay, power on. No standby. The button is very hard. Very hard button. Okay. The power is now okay. Okay. There is the IC there. Okay, we are going to check if the IC is not hot. Okay, it's cool. It's cool as ice. Okay, approved. Yes. Okay. Maybe next time. See you my other vlog next time. Okay. Okay. That's all as for now. Thanks for watching and thanks for liking.